Conversations, the podcast all about the impacts of climate change and how we can make a difference. I'm your host, Owen, and as always, I'm joined by my co-hosts, Dean, Luna, and Corbin. On this episode, we'll be talking about the effects of climate change on extreme weather, wildfires, and glaciers. But first, let's get into the weekly Climate Bites. For those tuning in for the first time, Climate Bites is our rapid-fire segment about recent major climate events. I'll turn it over to Dean to start.
Thanks, Owen. So to start off the weekly Climate Bites, it's not a climate event per se, but I'd like to talk about a brief review that was released by UNICEF on October 6th of 2023. So the article's titled Children Displaced in a Changing Climate, and it's basically a meta-analysis over the last 6 years that states that weather-related disasters caused 43.1 million internal displacements of children in 44 countries over a 6-year period, which is equivalent to approximately 20,000 child displacements a day. Now, obviously, some countries are more harshly affected than others, such as China, the Philippines, Haiti, Mozambique. Places that are that would often be considered in the global south, and so are more susceptible to such events. But just for a few more quick facts regarding that, floods and storms accounted for 40.9 million, or 95% of recorded child displacements. Droughts triggered more than 1.3 million internal displacements, and wildfires triggered 810,000 child displacements, with more than a third of those occurring in 2020 alone. So as you can see, things are quote-unquote ramping up as far as these extreme weather events.
Earlier this year, Maine saw a wetter and milder winter than previous decades. This left winter recreation enthusiasts disappointed. Picture your favorite snowmobile trails bare and the slopes going flat. The Camden Snow Bowl in Maine had to close to protect existing snowpack. Since 1949, nearly 80% of weather stations across the area have recorded an increase in winter precipitation falling as rain rather than snow. Ski resorts in the northeast region of the continent need to be open at least 100 days to be financially viable, among other necessary conditions. Human-made snow may not be enough to support certain activities which cover a lot of square mileage, like snowmobiling and cross-country skiing. Ice sports have proven to become more dangerous with thin spots and plane variability, posing a risk of injury or death to those who enjoy the brisk thrill of winter winds whipping down the slopes. El Niño is set to devastate the world's agricultural system and threaten lives and livelihoods. The global weather phenomenon, where the waters in the Pacific Ocean are warmer than usual, will persist through most of 2024. El Niño raises global temperatures and aggravates extreme weather events. The last decade has seen hottest on-record temperatures. The National Oceanic and Atmospheric Administration is predicting an increase of 0.2 degrees Celsius. This year's El Niño event is set to break records, amplifying existing current climate change conditions. Places like Australia and Indonesia are set to become parched and at risk for wildfires. This region is looking at a much rainier and muggier mild winter. Back to you, Corbin.
Thank you very much for that piece, Luna. The Horn of Africa has gone through 4, almost 5 dry seasons now and is experiencing the worst drought seen to date. Noted back in 2020 that Somalia, Kenya, and Ethiopia got 50 to 200 millimeters less rain than usual, the average annual amount of rainfall is 200 millimeters, which means the Horn of Africa is only getting 30 to 60% of their average rainfall, and to think they have been dealing with this since 2020 is absolutely mind-blowing.
Thanks for that, Corbin. Well, let's get right into it. So, got a little piece here about climate change and extreme weather events, and a lot of scientists say that climate change causes an increase in extreme weather events, but they just don't always do a great job at explaining how in easily understandable terms, much like how the term global warming has fallen out of favor despite a clear actual trend of global warming. Because it confuses people, there aren't a lot of good, digestible mainstream examples of scientific figures conveying how the two are related. I mean, sure, you can say that climate change is causing X, Y, and Z, but how? And that's what we're here for. Well, my colleague Corbin will be doing a bit of a special expose on wildfires later, but really, climate change causes all sorts of weather issues. Let's start with a couple of the more basic ones, and the most counterintuitive: extreme rainfall and snowfall. The same phenomenon actually explains both. So starting with snowfall is actually very interesting. So the correlation between warm air, snowfall, and rainfall. So the basis is that a warmer planet is going to evaporate more water, obviously. This leads to more warm air massing in the atmosphere since warm air rises. This is referred to as a convection or convection currents. Anyway, more warm air masses, and because warm air holds more moisture, you get larger rainstorms and extreme precipitation events. This leads to disasters aplenty, such as the Arizona I-10 flood in 2014, and the recent Burlington, Vermont flood in the summer of 2023, Hurricane Harvey dumping an absolute deluge of water on Houston in 2017, the 2021 Tennessee flash flood, which saw a fairly staggering 17 inches of rainfall in 24 hours, with 9 inches in 3 hours alone, and etc. You get the idea. But like I said, the same phenomenon leads to increased snowfall as well. That warm air traps more moisture in the atmosphere in winter too, not just in the summer, and when it falls it leads to huge snow events. So here in Maine, we had a huge winter storm down east, December of 2022, December 24th, I believe, that knocked the power out for over 130,000 people. There was that massive coast-to-coast winter storm this past March that hit everywhere from California to Washington to Texas to the Northeast, with about 80 million people, that's almost a quarter of the U.S. population, being under winter storm watch. There was, of course, February 2021's Winter Storm Viola that ripped across the U.S. and sent 170 million people under a winter weather advisory, caused over $20 billion in damage, killed about 300 people, and contributed to the historic Midwestern cold wave of that same year. All of this is made worse by a weakening jet stream. The jet stream is caused by the collision from the north of cold Arctic air with warm southerly air. The melting of Arctic ice caps lessens its temperature difference, causing instability, which in turn destabilizes the stream's path, allowing colder air to penetrate further south. Think of it like riding a bike. The faster you ride, the greater your stability and the less deviation from your course. If you ride slowly enough, you're gonna go back and forth until you just fall over. Well, if we're imagining the jet stream as sort of a more or less straight line going across the northern part of the United States, this clash of less cool air from the north and even warmer air from the south causes the same lack of stability and pushes your bicycle, the jet stream, further off course, further to the south, allowing this cold air to penetrate further into the south. Anyway, extreme rain and snow, precipitation in various forms, that's not even the half of it. We have droughts and wildfires, which my colleague will touch on a bit later, but also tropical storms and tornadoes. So tropical storms, otherwise known as hurricanes and typhoons, it's the same thing really, but they're just located in the Atlantic and Pacific respectively, are also worse because of climate change. And again, it's a complex mix of factors that causes it. So you have warmer oceans causing stronger storms in general, which leads to a 30-year increase in the amount of higher intensity storms. And just if you're curious, the way that works is essentially this warm water that evaporates more air, because the warm air has more water in it than cool air, as I'd already mentioned, which causes the burgeoning storm to suck up even more warm air and water, creating a positive feedback loop of sorts. And when this storm makes landfall, it leads to comparatively more rain, more flooding, and stronger winds than in colder ocean temperatures. So these warmer seas also mean wetter storms and more rainfall in general, like that lovely storm in Houston I mentioned earlier with Hurricane Harvey. You have sea level rise, contributing to a loss of coastal land and higher flood levels than a century ago. I've seen studies estimating that Katrina flooded 15 to 60% worse, that's 60, than it would have in 1900, and Hurricane Sandy flooded 300% more than it would have in 1900 because of this. Then you have the warming atmosphere again, causing hurricanes to move more slowly and quote-unquote stall more often, just sort of stand in place in the ocean. Now, scientists aren't positive why this happens yet, but it is happening, and this, of course, gives storms more time to batter and flood coastal areas. What with all the warming in the Gulf of Maine, these past several decades, we might be looking at a hurricane of our own sometime in the not-so-distant future. A real one, not the tangential effects of one, like we had in this past Hurricane Lee. And it's the same with tornadoes. We're getting fewer days with tornadoes on average, but a higher concentration of days with 30 tornadoes or more, stronger tornadoes, and a higher density of tornado clusters. Tornadoes are a bit harder to gauge, as they don't have as much of a geographical impact as hurricanes, but there is a trend, and it's becoming harder and harder to ignore. And now I'm going to turn it over to my colleague Corbin to give his piece about wildfires.
Wildfires have become a more common occurrence in the world recently. Since 1983, it has been recorded that almost 70,000 wildfires happen each year, regardless of the cause. Starting on January 1st, 2023, and ending on September 6th of 2023, approximately 40,444 wildfires, burning 2 million acres of land, have already been recorded, and it has not even been a full year yet. Warmer, drier, and more humid weather that is associated with climate change is great conditions for both natural and human-caused wildfires to thrive. It also makes combating wildfires more difficult as the fire has better conditions to spread and increase. Climate change can be related to wildfires due to the droughts and dry conditions allowing wildfires to burn harsher and longer than usual because of the more flammable terrain it produces. Frequently warmer days can dry out trees and plant life and cause heat stress on an environment, in turn allowing anything that can start a fire more prone to do so. It is important to note that although it is more probable that something like a spark or something human caused a wildfire, it is possible for, say, lightning to strike a tree and catch it. In conclusion, it's probable from both human and or an elemental hand that a wildfire could start. Regardless of cause, climate change affects wildfires by ignition, previous state of whatever is burning, and the combat strategy to stop it. Wildfires are recorded to be primarily a human-caused problem, as 85% of the wildfires recorded in the U.S. were due to human causes. Human causes are anything from malfunctioning equipment, unattended campfires, incorrectly disposed recreation, for example cigarettes, prescribed burning that got out of hand, or even flat-out arson. Aside from us humans, the two main causes of wildfires are lightning and the climate changes behind said lightning. Longer and warmer summers coupled with ever-increasing carbon emissions create strong updrafts in the climate, making convection storms more frequent. Staying on the topic of lightning, there are two kinds of it. We have hot and cold lightning. Cold lightning is usually shorter in duration in comparison to hot lightning, so it is rarely the cause of wildfires. Though hot lightning has less voltage than cold lightning, it lasts longer, meaning the heat it conducts has longer to spread and start wildfires. A study done in 2014 suggests that there is a 12% increase in the frequency of lightning storms for every 1 degree Celsius increase in the temperature. Though it is exceedingly rare, it is worth noting that other than lightning, volcano activity is associated with wildfires. One example is the Kilauea volcano in Hawaii that erupted sometime in March of 2011, causing a 75-acre wildfire. Actions against wildfire consist of learning how to use outdoor equipment properly, making sure you attend and manage campfires, not forgetting to put it out, and education on wildfires in general to correctly protect yourself, others, and the environment. Most of the wildfires in the world are avoidable and are only caused by human error, reinforcing the fact that we need better general education about fire, if not wildfire specifically, so we can correctly use fire instead of letting it get out of hand. Wildfires threaten lives, destroy property, and harm our natural resources. Learning safe escape routes and being properly prepared for a wildfire or natural disaster are key to your safety. Avoiding activities that involve flames or sparks on a dry day is a good prevention method, as well as ensuring campfires are in open locations away from flammables and properly putting them out. Droughts, dry air, gusts of wind are some indicators that a fire might not be the best thing to do. The severity of a lot of recorded wildfires can be attributed to being fueled by gusts of wind and a lack of water from droughts. Droughts are a good indicator that the environment is prone to being more combustible than usual, as the environment is drier and probably hasn't had precipitation in days to months depending on the area. August is the wildfire season, as areas get increasingly drier, making them more susceptible to wildfire. Droughts and climate change have played a part in this, as they are making temperatures hotter or colder respectively throughout the seasons. Droughts are prolonged periods of time, normally several days to months, where there is no precipitation, causing the environments to be drier than usual. Dry environments make great fuel for wildfires to thrive, and the ever-changing climate allows more parts of the environment, like vegetation, to be vulnerable to fire. Climate change is also changing the nature of our winds, making gusts more powerful or the air itself fluctuating with temperature, further fueling the wildfires. Climate change not only contributes to the frequency and spread of wildfires, but to their duration as well. With the climate changing and becoming warmer and drier, wildfire season itself is lasting longer, allowing any existing wildfires to keep burning and making them increasingly difficult to control or put out. Incorporating fire-resistant material in buildings as well as increasing the spacing between buildings could help make the August wildfire season go by easier. Even removing dead trees that could be used as fuel for a wildfire is a positive impact you could have. The global climate has changed enough by now that some may consider July to be the peak of wildfire season, as the seasons have gotten hotter for a longer time and getting colder more quickly. To summarize, wildfires are one of the very few things associated with climate change that are 9 times out of 10 caused directly by humans. Rather than being a byproduct of the largely man-made change in climate itself, wildfires can be a natural occurrence but are much more often found to be human-caused events. With that in mind, improved education, a safety plan, and understanding the correct and proper surroundings to safely use fire for essential or recreational purposes can have a huge effect on the severity of wildfires. Prescribed fires, which are fires that are manufactured into a controlled burn of an area to help the ecosystem by removing invasive species, reduce insect populations, and they can help prevent wildfires by having the combustibles already used in controlled burning. Prescribed burning also enriches the soil with the ash of the burnt vegetation, further improving the area and making it ready for the natural species of plants and animals. By supplying the nutrients through the ashes faster than the area would have gotten it from natural decomposition of the vegetation, the area and the surrounding environment can start to build itself back up and thrive.
Well, we've talked about general extreme weather. We've talked about wildfires and why they matter. Now let's switch gears and talk about ice. So it's pretty well established that the global temperature is rising. Temperature records have been shattered globally every year for the last several years, sequentially now. And temperatures have gone up about 1.44 degrees Fahrenheit above pre-industrial levels. That's 1.2 degrees Celsius. But the poles have actually warmed up quite a bit more than that. According to NASA, the poles have warmed 3.5 degrees Fahrenheit or more. And there are a few reasons for this, according to scientists, namely one Patrick Taylor from NASA's Langley Research Center. Essentially, large weather systems carry energy up to the poles, which melts the ice. When this ice melts, as ice itself is extremely reflective, it has a high albedo, this means that less energy is reflected further, increasing the temperature. The albedo is the portion of light that is reflected by a surface. There are a few additional factors as well, which is the increased effect carbon dioxide and warm water vapor has in this region, as well as the thinner troposphere over the poles. The thinner troposphere means that less energy is required to increase the temperature, which also increases overall warming. Now, I could go on, but I don't think it's too controversial to point out that warming is worst at the poles. More cold, more ice, greater effective heat on the ice. When you heat ice, it melts. So that explains why the warming is greater at the poles, but let's dive into how the glacial melting actually works and the additional implications it has. So just to go over what a glacier is real quick, it's just a huge mass of snow and ice that has been compressed together and sticks around year-round. The U.S. has some, like in the Rockies, or pretty much all of Alaska, or the Sierra Nevada, but basically glaciers just accumulate ice and naturally lose some of their mass to meltwater going off into rivers or the ocean. For a long time this was pretty steady, but since the Industrial Revolution, a lot of snow and ice mass has been lost globally in the form of water melting into the ocean. Glaciers themselves cover about 10% of the Earth's surface and represent 70% of the planet's freshwater content. And that is what is leading to the increase in sea levels globally. The sea level has risen 8 inches in the 20th century, and 2 inches in the past 20 years, which means that it's accelerating. This is, unequivocally, not very good. Not only due to the sea level rise, which can and will displace human settlements and coastal communities, but also cause habitat destruction. Many animals, like penguins and polar bears, rely heavily on these habitats. There's also the additional negative factor of more ice melted causing more warming. When ice melts, it leaves a darker surface behind, which absorbs more heat, which leads to more warming, which perpetuates a positive feedback loop of warming. This becomes even worse when you realize that ice reflects about 90% of sunlight and absorbs 10%, whereas ocean water is the opposite. It absorbs 94% and reflects 6%, further contributing to this feedback loop. Ice melts, creates more water, sea level rises, which leads to more heat being absorbed by the ocean and even more ice melting. So what mechanism causes it? Well, the sun or trapped greenhouse gases heat up the ice, and that ice melts. Large amounts of sediment, fresh water, nutrients, etc. are released into the water. This precipitates the coastal sea level rise that we mentioned, but also helps explain things like habitat displacement, as well as the poisoning of coral reefs. Remember, one of the things that lets us know global warming is real is by taking samples of the water and rocks in affected areas and analyzing them for content. And by doing this content analysis, we can see chemicals settling into rocks and water, letting us know that yes, it is in fact the burning of fossil fuels that is causing these changes. So we've talked about what it is and how it happens, as well as some of the effects. Sea level rise, extinction of species, more extreme weather events, less fresh water for the population, which also means less hydroelectric generation. But let's take a more positive turn. What can we do about it? Well, other than straight up curbing behaviors that worsen climate change, like factory farming or burning fossil fuels, I've seen solutions proposed from a giant polar dam to block runoff from the Jakobshavn Glacier, that's the glacier that produced the iceberg that sank the Titanic, by the way, to collecting runoff water from melted glaciers, refreezing it, and recreating ice blocks to bolster the ranks of remaining glaciers, if you will. But at the end of the day, all of those are temporary solutions to a seemingly permanent problem, and I really just think we need to move away from fossil fuel sources of energy more quickly. You know, nuclear, solar, wind, as well as greater government support for them. Because this isn't something people can do on their own. I really believe that going forward, this is the path we'll have to take so more of our glaciers don't disappear forever and take the planet's ecosystem with them.
All right, that's all for this week's episode. Thank you to everyone for tuning in. If you enjoyed this episode, please leave a review on your favorite social media platform and share it with your friends. Also, if there are any topics you'd like us to cover in the future, feel free to reach out via social media or leave a comment on our YouTube channel. We'll see you next week when we'll be covering global degrees of warming and what effects are projected at certain thresholds, the impact of a changing climate on tourism industries, and the relationship between climate change and mental health.